All right, let's get into it. Today, we're going to pull back the curtain on the surprisingly complex science that kicks into gear every single time you start a diesel engine, especially on a chilly morning. It's a story of incredible heat, really clever physics, and some serious digital precision.
Okay, so let's jump right into the core problem that every diesel owner has felt in their bones. See, unlike a gas engine with its spark plugs, a diesel relies on pure, raw heat from compressing air to ignite the fuel. But when it's cold out, that simple, beautiful principle runs headfirst into a massive wall.
And that wall? It's the engine block itself. You have to think of it as a giant, cold metal sponge that is just desperate to soak up heat. All that critical thermal energy you're trying to build in a cylinder gets sucked away by the cold metal before it ever gets a chance to light the fuel. So, how do engineers fight back against physics?
Well, you fight the cold with even more heat. The answer, of course, is the glow plug. But as we're about to find out, these things are so much more than just simple little heaters. They're actually precision-engineered instruments designed to do something pretty extreme.
Just how extreme are we talking? Well, take a look at this number. Modern ceramic glow plugs have to hit an incredible 1,000 degrees Celsius, that's over 1,800 degrees Fahrenheit, in as little as 2 seconds. That's the kind of insane instant heat you need for a reliable start every single time. Okay, so the big question, right? How in the world do they get that hot, that fast, without just melting? Well, the answer is this brilliant partnership between good old-fashioned physics and modern digital logic, and they work together in two distinct layers of control.
So, layer 1 on the left is the super clever physical safe that's built right into the plug itself. Think of it as the analog safety net. The second layer, on the right, is the digital brain, a control module that's making all the high-speed, precise decisions. Let's dig into that physical safety net first.
Now this is where things get really elegant. The plug actually has two different coils inside. The heating coil at the very tip gets white hot, right? Well, that heat travels back and warms up a second coil, the regulating coil. Now this coil is made of a special material where its electrical resistance just skyrockets as it gets hotter. This creates a natural choke point, automatically throttling the electricity to prevent the plug from cooking itself. It's a fantastic built-in self-protection mechanism.
But here's the thing. That physical failsafe, that's just one piece of the puzzle. As you can see from this system map, there's a whole lot more going on. That self-regulating feature is really just the backup plan. The primary control comes from a dedicated computer. What we see here is the GCU, or Glow Control Unit. This is that digital brain we were talking about.
And this digital brain isn't just guessing, it's a total data junkie. It's constantly pulling in information from the main engine control unit, the ECU. I mean, look at this list. It's checking the engine's coolant temp, the outside air temp, engine load, even the battery's voltage and the barometric pressure. It crunches all of this to make one critical decision.
And here's its secret weapon for getting it just right. Instead of just sending a steady stream of power, it uses a technique called pulse width modulation, or PWM. The easiest way to think about it is like flickering a light switch on and off incredibly fast. By changing how long the on pulse is compared to the off time, the module can deliver the perfect amount of energy to get those plugs screaming hot and then hold them at a very specific temperature later on.
And this super precise PWM control isn't just a one-and-done kind of thing. It's actually used across 3 totally separate stages of the engine's operation, starting the very second you turn that key.
So if you look at this timeline, you see the 3 phases. First up is preheating. That's the initial blast of energy, when that little coil light pops up on your dash. Next, as you're actually cranking the engine, it's in the starting heat phase to keep things hot. But surprisingly, the most important part for a modern, clean engine happens after it's already running, in that final post-heating phase.
Yeah, this final phase is called post-heating. For several minutes after the engine is already started, the glow plugs actually stay on, just at a lower controlled temperature. This is the secret sauce for making sure a modern diesel runs clean right from a cold start. And it's a phase most drivers have no idea is even happening.
So for a few minutes after the engine fires up, the control module keeps those plugs active. This makes sure every last drop of fuel gets burned completely while the engine block is still cold. And what does that do? Well, it gets rid of that ugly puff of smoke, it smooths out a rough, shaky idle, and most importantly, it drastically slashes harmful emissions.
So, we've seen how brilliant and complex the system is when it's working perfectly. But what happens when that delicate control fails? The consequences can range from a bit of smoke and a rough idle all the way to a complete engine meltdown.
And the control is getting even more precise. To try and prevent failures, engineers are adding more sensors. Some of the newest glow plugs actually have tiny pressure sensors built right into the tip. They can literally feel the combustion happening in real time, creating a perfect feedback loop for the ECU. But, of course, more complexity also means more things that can potentially go wrong.
So this is probably the most crucial part for anyone who drives a diesel. With all this tech packed in there, recognizing the symptoms of a failure is absolutely key to preventing some major, and I mean majorly expensive damage. And this table really lays it out. The consequences are pretty severe. If the control module sends too much voltage, the tip of the glow plug can literally melt off and drop into the cylinder. That's catastrophic damage. Not enough heat leads to carbon buildup and hard starts, and if that post-heating phase we talked about fails, that's when you get that telltale white smoke and a really rough idle. So if you ever noticed any of these signs, it's tough to start in the cold, you see that puff of white smoke when it fires up, the idle is shaky, or that little glow plug warning light on the dash just won't go off, that's a clear signal. Your engine is telling you the control system needs attention right away. This circuit diagram really puts it all into perspective, doesn't it? You can see how the control module is the hub, the brain of the whole operation. It connects all the sensors, the relays, the battery, and finally the plugs themselves. A failure in any single part of that chain, a bad relay, a faulty sensor, can bring the whole system down. Ultimately, that's what this all comes down to, right? Modern glow plug control is this perfect blend of rugged material science, that self-regulating coil, and the intelligent, lightning-fast oversight from the digital control module. And that's really the main takeaway here. What looks like a simple heating element is actually this incredibly sophisticated microprocessed system. It's this hidden technology, this beautiful dance between physics and digital control that lets massive diesel engines start reliably in the absolute coldest weather, all while helping to keep our air clean. It really is the invisible heat that powers our world.